Hello guys, welcome to drilling-academy.com. I'm delighted to present you this video about the control system of surface BOP. The entire control system of surface BOP is such a complex and large system. So if I make it in one video, it will be lengthy. It will be more than will be close up to 1 hour. That's why I make it to make it easy for you guys to follow. I make it into two parts. This is part one about the manifold. I will explain the operating mechanism from the moment you press a button at a remote control panel to how the fluid flows through the process and the light bulbs are lit up. And part two, we will discuss the annular BOP and the diverter control. Now let's start. This picture here shows you the entire system, how it's made up. There are actually three major parts. The first one is the remote control panel. There are two remote control panels. This is an example, right? One is located in the ruler's cabin and one is located in the tool pusher's office. And the second major important part is the Kumi unit itself. And here there are reservoir, there are manifold, rams, and H4 arms and H7 valve. There is manual annular control for controlling the annular BOP, and there is also diverter control panel here. And of course, the last component is the actuator, which is the BOP or diverter itself. So the communication between the Kumi unit and the remote control panel is all done in form of electric signals, right? You press a button in here, the PLC will send the signal, the electric signal to the Kumi unit. And at the Kumi unit, there is air pilot, there is hydraulic pilot, and there is hydraulic power fluid and electric signal all work together with the BLC to produce the output, which is the power fluid sent to the actuator, the BOP or diverter itself, right? And the Kumi unit will also send the electric signal back to the PLC in the remote control panel for displaying flow, totalizer, pressure gauges, and the light bulbs. This is the close-up view of a modern model of a remote control panel. This is a fully touch screen. There is no physical push release button, but there are all touch buttons in here. And there is one master touch button here. You touch, you push and hold to activate the functions on the BOP and the diverters in there. On this touch panel, there are displays of alarms and fault. You can do the fault finding on this panel. And this picture shows you the sample of a Kumi unit. This Kumi unit here has one triplex electric pump here, this one here, and three pneumatic air pumps. The air pumps are the primary pumps, and the triplex electric pump is the secondary pumps. These are the junction boxes, right? These are the three flow control valves or manipulator valves manifold, right? And this is the final bypass valve. These are the accumulator barrels. These are the control panels here, and also diverter control panel. And now this is the classic diagram that everybody uses it to explain how the fluid goes through the system and how the whole system works. To me, this diagram is too busy. The system itself is complex, and my job is not to complicate it more. My job is to make it more simpler, okay, much simpler for you to understand it. I guarantee if you spend hours reading this diagram and manual, and even going around asking people, you don't get much out of this diagram. To me, this is a no, okay? But I use this one. From this busy diagram, I turn it into this diagram here, which is more organized, clearer, more transparent, easier for you to follow and to understand. You have the air pumps here, which is here three air pumps here. They are the primary pump, and the electric pump is secondary pump. In some systems, you have two electric pumps. One is supplied from emergency generator, and one is supplied from the main bus bar. All right. So the one which is supplied from the main bus is primary, and the one which is supplied from the emergency generator is the secondary. This is the reservoir. So for the entire system, we have the accumulator banks here, and you have only one flow meter. All right, it will sense the flow that the fluid flows through the system upon the activation of every function. And now there are 4 branches in this system. This system is a 3000 psi system, working system pressure 3000 psi. Okay, the 3000 psi line is colored in red, and the dark brown lines are regulated pressure. The purple line here, they are all 1500 psi, and whatever is in yellow is the vent line. Okay, so the first branch is a manifold. All right, here is the manifold. It supplies power fluid to all the RAM BOPs. It has 2 inputs. One input is 3000 psi, and another input is 3000 psi regulated down to 1500 psi. This regulator here is manual regulator. It is only controlled and adjusted locally, manually at the cooling unit. You can't control it, you can't adjust it from any remote control panel. So these 2 inputs are fed into the high-low bypass valve. So on the high-low bypass valve, if you choose low, all right, it will take the 1500 psi and supplies to all the functions on here. These functions are upper pipe ram, lower pipe ram, reservoir ram, line shear ram, HCR valves on choke line, HCR valve on kill line. And if you press high at the remote control panel, or you go down to the cooling unit and you turn the valve handle to high position, it will take the high-low bypass valve will take the 3000 psi fluid and feed to all these functions here. And there is one common pressure gauge for the manifold. Okay. The second branch is the annular BOP and diverter. All right, this line here, this branch here. Okay. This branch here, it has one remote air operated regulators. All right. This air operated regulator is also manually controllable from the cooling unit. So you can either increase the pressure in the line or decrease the pressure in the line from remote control panel. You press a button from remote control panel, or you can go down to the cooling unit and turn the valve handle to you press the button, increase or decrease, to decrease or increase the pressure in the line. Here, imagine we are at the remote control panel, we press increase, the pressure in the line is increased. When we press decrease, the pressure in the line is decreased. All right. And the next branch is the diverter manifold. This branch here. It supplies power fluid to the annular flooding valve and the 2 overbore lines of the diverter system. Right. The 3000 psi fluid is regulated by this manual regulator. This regulator is manually controlled only at the local cooling unit. You go down there and you turn the handle to set it at your desired value. It is set usually in the range from 500 to 1500 psi here. All right, you can't control it. You can't adjust it from remote control panel. And the last line, the last branch is for the overshot packer. All right, the overshot breaker is operated at 1,500 psi. Okay, so this is the manual regulator. It is only adjusted and controlled locally, manually, and the cooling unit. All right, it regulates the pressure down from 3,000 psi to 1,500 psi here. You again can't adjust it or control it from the remote control panel. You can't. All right, so now when you activate any functions of these, all right, what will happen? The pressure gauge on that line, on that branch will drop, and the pressure gauge on the main line here, we call it the accumulator pressure gauge, will also drop. And then the primary pumps will kick in if the pressure is dropped down to 2,700 psi, which is 10% drop from 3,000 psi. If the pressure in the main line continues to drop to 85%, which is 2,550 psi, then the secondary pump will kick in, or will charge the system up to 3,000 psi, and the pressure in that corresponding line will also be charged up. Now, for example, we press open to open the annular BOP. So we will see the pressure line on the annular will drop, and the pressure on the main line also drop. And if it drops 85%, all 4 pumps will run and charge the system up, and the pressure comes back up. In this first part here, we will examine only the manifold, right? Because it is quite complex, it's quite lengthy with the manifold already. In the second part, we will discover and discuss the annular BOP and the diverter and the overshot. Now this is, again, we come back to the close-up view of the remote control panel. We have the press and hold push button in here. We keep it depressed all the time if we want to activate these functions on the BOPs and the diverter. And these are the gauges that we pay attention to. We have the flow meter to show the volume of a function. We have the accumulator pressure gauge, which is supposed to be at 3,000 psi. The manifold pressure gauge, which is supposed to be at 1,500 psi if you choose low on the high-low bypass valve. The annular diverter pressure gauge is set in the range 200 to 100 or 1,500 psi, so it is where you last set it. And the rig air should be in the range from 775 psi to 120 psi. Minimum is 75 psi. Okay, so for all the BOP functions here, if it's closed, it is red. The red light pop is on. If it is at the open position, the green light pop is on. But for the HCR valve, it's the contrary. When it's open, it's red. And when it's closed, it's green. All right? And don't forget about the manual gauge valve in front of the HCR valve. All right? It is for isolation if you have to repair the HCR valve. All right, now we come to the manifold. As we said before, the manifold has 2 inputs here, low and high. All right? And the regulator is manually controlled and set at 1,500 psi. It supplies power fluid to all the RAM BOP and the 2 HCR valves. And all of these control valves here looks like this. And the high-low bypass valve also looks like this. All right, we call it manifold 3/4 control valve or manipulator. How it works? For example, when we press and close at the moment the upper pipe ramp, because all the rams, BOP and the HCR, they will work in the same mechanism. So we just consider one example, which is we take the upper pipe ramp, any pipe ramps in here, anything in here, we take the upper pipe ramp. When we press close, we expect the manifold pressure gauge and the accumulator pressure gauge to drop, flow meter to run. At the moment the upper pipe ramp is open, the light bulb is green. We expect to see this light bulb to be off. The red light bulb for close will start blinking and lit up. Nothing will be happen to the annular diverter pressure. All right. Now we do it. We press close. All right. You see light bulb blinking. This light bulb is out. Right. Flow meter runs. Okay, these two gases drops, they drop and they come back up. All right, flow meter runs and then stop. Right. All right, the same thing happens when we press open. All right, we expect to see this light bulb, the closed light bulb, to be off and the green light bulb to be blinking and then lit up. RAM BOP open. These two pressure gases here, manifold and annular to drop and come back up, flow meter to run. Okay, let's do it. Nothing should be happen to the annular diverter pressure gauge. See that? Exactly as what we just said. Right, this is what we expect to see. In reality, it should be this way. Okay. And now let's examine what drives them, what makes them happen this way. First, we have to understand how the 3-4 manipulator control valve and high-low bypass valve work. The 3 stands for 3 position, and 4 stands for 4 ports. So the valve has 3 compartments or 3 positions. This position is called closed, all right? This position is at the middle position, the blocked. All the ports here are blocked. See this? Blocked. Blocked. All right? Doesn't go anywhere. Blocked. And this port is vented back to the tank. Okay? And this position here, this port is routed to this output. This input is routed to this output. All right? And it will be vented to the tank. Okay? And this port here, and this position here, the input here is routed down here and comes out here. All right. And on the modern system, they use pressure switch to sense the pressure in the line. And the pressure switch, upon sensing the pressure in the line, it will send the electric signal to light up the light pop in the control panel. In the old day, they don't use pressure switch, but they use proximity sensor to sense the position of the valve. But that's the old day. Now, modern day, they use pressure sensor, which is more compact, more cost-saving, and more precise. And when we press the button open, here, this is open button, what will happen to this valve? This valve has, this is air piloted, sorry, my mistake, air piloted. Air will be supplied to this end. It will pull the valve sleeve from where it is right now at closed position to this open position here. All right, this pink square will move to here. All right, and this open line here will be pressurized because the input here will feed through it. Okay, it will send the signal, send the pressure, and send the signal to light up the pop here. At the present time, this valve sleeve is in closed position. That's why now the pressure is in the closed line, and this pressure switch senses the pressure in the line and it sends the signal to light up the closed light pop here. But once the valve sleeve is moved to open position, this will swap. Okay, let's take a look here. We press open, air acts on here, pull the valve sleeve. All right, this light pop is out. This light pop is on. Okay, the fluid goes through here, down here, come out here. Okay, the valve handle shift from closed to open. See that? And now, if we press close, it goes back the same way. All right, the same thing happened again. What happens if we go down to the Kumi unit? We hold the valve handle and we manually do it. For example, now the valve is at the closed position and we turn the valve handle. This time we don't press the button from the control panel anymore, right? So we turn the valve handle manually. The valve sleeve will shift from this closed position to the open position, this position here, all right? And the same thing happened as before, right? This light will be out, this light will be on because the open line will have pressure and the closed line is vented now. Okay, we pull the valve sleeve See, the fluid is fed through here, down to this here, and this sensor here senses the pressure and sends the signal to light up and pop here. And this line here, the open line here, sorry, the closed line here is routed here and goes to the tank. It's vented. There is no pressure in the line. The pressure switch doesn't send the signal, so this light bulb is out, is off. So that's how the 3-4-way control valve works. Now let's take a look into this lower pipe ram. We take the example with one lower pipe ram. It would be the same for upper pipe ram, variable bore ram, shear ram, choke, and QSL valves. Okay, the same way it works, right? So at the moment we choose low for the high-low bypass valve. So we take 1,500 psi down here. For all the rams, VBR, upper pipe ram, lower pipe ram, Q line, SR, choke line, SR, we only need 1,500 psi. We need 3,000 psi for shear ram. We'll come to that point later. So at the moment, the pipe ram is at the closed position. All right. So the 1,500 psi is routed to this line here, comes down to this line, go to this closing chamber, goes to this closing chamber. So this pressure switch here senses the pressure in the line. It is set at 1,000 psi. So now we have 1,000 psi. It's more than 1,000 psi. So it senses this value. It sends the signal to light up the closed light bulb here. When we press open, this is open here, the air will be acting on this side to pull the valve sleeve from here to here, right? And the fluid will be fed through here, comes out here, and fed to the open line here. This is the open line. The open line will change state from vent to pressurized. And the pressure sensor switch here will send the 1,500 psi in this line and send the signal to light up the green light bulb here. The flow meter will run. The red light will be off. We already said that. The accumulator pressure and the manifold pressure gauges, they all drop. The pumps will run to charge up the system. And then the accumulator pressure gauge and the manifold pressure gauge will come back up and the flow meter will stop running. The valve handle will shift from closed to open. Now let's take a look when we press open. And now let's see the magic happens, right? All right, see the line is changing state from vent to pressurized and from pressurized to vent. And the light bulb is lit up here. See that just happened in a snapshot, right? And now what happened if we close the ram BOP? All right, at the moment the ram BOP is in the open position. All right, we release a button, the valve stays at the last position where it was before. All right, so now when we press close, the same thing will happen here. All right, the valve, the air will be acting on this side and it will pull the valve sleeve from open to closed position. Fluid will be fed to this line and comes down here and comes out. Okay, comes down to the opening chamber, comes down to opening lines in here. The opening lines will change state from vent to pressurized. The closing line will change state from pressurized to vent. So therefore, the pressure switch here on the closed line will stop sending the signal to the light bulb, and the light bulb, the green light bulb on open will be out, it will be off. The pressure switch on the open line here, it will sense the 1,500 psi fed through it here. Okay, we send the signal to light up the red light bulb on close. We'll see the flow meter run. We'll see the accumulator pressure gauge and manifold pressure gauge drop. The pumps will run and charge up the system, and the accumulator pressure and manifold pressure gauge will come back up and flow meter will stop running. All right, and the valve handle will shift from open to close. All right, now let's do it. And now the magic happens. All right. See that? Now the BOP, the ram BOPs are closed. See that? Just happened in a snapshot, right? Now we come to the blind shear ram. For blind shear ram, as we said, to shear the drill part, you need full 3000 psi. Therefore, on the high-low bypass valve, you either at the remote control panel, you press high, button high, or you go down to the local Kumi unit and you turn the valve handle to the high position. So in this case, we press high button. The pellet air acts on this side, it pulls the valve sleeve to this side, and the pressure sensor here will send 3000 psi is fed through here, okay, and it sends the signal to light up the high light pop here, and 3000 psi is routed all the way through to the opening chamber here. All right. Now, when we press close to shear the part, we expect to see flow meter running, and the lines here will change state from vent to pressurized and pressurized to vent, and the pressure sensors here on the will send the signal, the pressure on the line, and send the signal to the light pop. All right, the one which will be vented later will stop sending signal, and open light will be out. Accumulator pressure gauges and manifold pressure gauges, they all will drop, pump will run, charge up the system, and accumulator pressure gauge and manifold pressure gauge will come back up. And after finishing the function, the flow meter will stop running. Let's take a look. Air pilot acting here, okay, valve sleeve moves, fluid comes down here, the line changes state, all right, move in here, and you see flow meter runs, all right, pressure gauge drops, pumps run, and pressure gauge come back up, flow meter stop running when the BOP finishes the function here, all right, and the valve handle shifted from open to close. Now, what happens if you go down to the Kumi unit and you manually turn the 3/4 control valve to the middle position? I call it the block position. Okay, why is it blocked? Because at the middle position here, all the ports, input, output, every port, all ports are blocked. And this port here is vented back to the tank. But the output ports here, they are all blocked. They will contain the same pressure as the last time they were activated. So now we consider this case, the RAM BOP. Last position is open. So the open line is pressurized. Closed line here is vented. All right. That's why the pressure sensor on the open line senses the pressure and sends a signal to light up the light pop on open. All right. Now, if I go down to the manual, to the local Kumi unit, I grab the valve handle and I turn it to the middle position. There is no air acting on both sides, right? So the valve is manually moved from open to middle position. Nothing changes to the lines in here, right? Because all the lines are blocked here, internally inside the valve, all the ports are blocked. Therefore, the open line still remains the pressure in it, 1500 psi. And the pressure switch here still senses that value and sends the signal to light up the open light pop. On the closed line here, it's still vented. It was vented before and now it's blocked, so it's still vented. It contains the same pressure, low pressure. Therefore, it doesn't send any signal to light up the closed light pop here. All right, so that's what happened when you turn the control valve to the middle position. You don't do it in drilling operation. You only do it when you are in rig move or you are maintaining, you are servicing your BOP. When you service your BOP, you open all the BOP functions and you place the valve, the control valve at the middle block position. All right, guys, thank you very much. I think this is the end of the part 1. I hope you guys did get a full picture of how the 3/4 control valves work, how the lines are lit up, and how the fluid moves around the system. I'll see you soon in part 2 for annular BOP and diverter control. Thank you again and bye bye.